In this video, we are going to learn set identities by Kandula Tirupati. Sets, we can denote these sets, the capital letter of A, B, C like this. Universal set is set to be I, or also we can write that mu. It's a universal set. The complement is a dash. A dash is called complement. The proper subset is, we can write A subset B. It's a proper subset. And empty set means that is pi. Also we can write this is without elements is called empty set. And the union of sets. Union of sets means A union B. Union of sets, we can read it as A union B. Intersection of sets is A intersection B. Difference of sets is A public B, A minus B also. A is a set, it is always subset to universal set. A is a set, it is always subset to any set is a subset to universal set because I is universal set. And every set is subset to each other. A subset A, that means every set is subset to itself. A equal to B means if A subset B and B subset A, that means A is a subset and B is a superset, and again A and B is subset and A is superset, then uh, from these two we can write A equal to B. That means, and what is empty set? What is empty set? Empty set is always subset of A. That means empty set is subset to every set. So union of sets, C equal to A union B. That means a element is in A and another element is in B. We can say that A union B is equal to that element belongs to A or element belongs to B. X such that X is an element in A, X belongs to A or X belongs to B. We can write this A union B is X such that X belongs to A or X belongs to B. Now observe this, A is a set and B is also a set. A union B equal to, we can write this A union B, and also B union A is also both are same. We will get the same answer, A union B equal to B union A. The Venn diagrams are given here. A union B is this one and B union A is also same. A union B equal to B union A, it's called commutativity. That means we can add two sets in any way. A add B to A or add A to B, we will get the same answer. So this is called commutativity. Intersection of sets. Intersection of sets, that A intersection B is equal to A intersection B is equal to X such that X belongs to A and X belongs to B. That means and means it should be in A and the same element should be in B. X belongs to A and X belongs to B. That means it should be in A and it should be in B. That means it should be here only. This area is called intersection of sets. And also it applied to that A intersection B is equal to, we can write B intersection A. Both are same because you can intersect A to B and B to A is also, we will get the same answer. So commutativity is applied to this intersection of sets. associativity of sets. A intersection B intersection C is equal to A intersection B intersection B. Now intersection apply to BC and then after A, and you will get the same answer with A intersection B after intersection C. We will get the same answer. Distributivity. Distributivity. A union B intersection C is equal to A union B intersection A union C, and A intersection B union C equal to A intersection B union A intersection C. Idempotency, that is A intersection A equal to, we will get A, and A union A is equal to also A. And domination, A intersection pi equal to pi, A in union mu is equal to I is equal to I. This is universal set. You can add to any set to universal set, we will get the same universal set. And in the intersection there is no common element A and intersection this pi, so we will get without elements set, that is pi. Identity, what is identity? A union pi is equal to A, that means if you add pi to A, we will get A, and A intersection I is equal to A. This is called identity. Complement of intersection and union. A union complement A, that equal to mu I universal set, and A intersection a dash or A complement, that equal to pi. There is no common element because A complement means that is mu minus A or I minus A. We can write I minus A. So De Morgan laws, A union B whole power dash A union B whole power complement is equal to A complement intersection B complement, and A intersection B whole power dash equal to A dash union B dash. Difference of sets, C equal to B oblique A and X such that X belongs to B and X is not belongs to A, that means B minus A. Difference means B minus A, that means A element should be in X such that X belongs to B, it is in the B, but A is removed from this set, so it is not in A, and it is not in A. X not belongs to A. So this is the difference of sets. This is B minus A. 11th one. This is B minus A. That means X belongs to B, but X is not belongs to A. This equal to, we can write B intersection B intersection A dash, B minus A equal to B intersection A dash. The 12th one, for example, A minus A, what is your answer for this question? A minus A equal to pi. It's a null set. Here B and A are separated and there is no common element B and A, so such a sets are called disjoint sets. Where A minus B is equal to, we can write A minus B is equal to A, because there is no common element to deduct from A. So A minus B, there is no change in A, that's why it's equal to A. And also we can write there is no common A intersection B is equal to pi. What is intersection? A element should be in A and a element should be in B. There is no common element A and B. So A intersection B equal to pi. For example, 1, 2, 3 is there in B and 4, 5, 6 is there in A. What are the common element? There is no common element to write in A and B. So these are disjoint sides. So intersection B equal to pi. So Cartesian product, that is C equal A cross B, is called Cartesian product. So x comma y are two elements. That means x belongs to A and y belongs to B is called Cartesian product. Sets of numbers, natural numbers are, we denote the set is n, and whole numbers is denoted by w. We can denote this not n, w, and the integers are z. Positive integers are z plus, negative integers are z minus, rational numbers is q, and real numbers is r. The complex numbers is c, and the integers are I. Rational numbers and integers. Natural numbers, counting numbers are called natural numbers. Counting numbers are called natural numbers, that equal to 1, 2, 3, 4, 5, so and so. It's a set of 1, 2, 3, 4, 5, so and so. Whole numbers, counting numbers are with 0 and 0. 0, 1, 2, 3, 4, so and so is called whole numbers. Integers, whole numbers and their opposite and 0 is called integers. Positive integers, that is n, 1, 2, 3, 4, so and so. And negative integers, that is negative values, all the negative values, minus 3, minus 2, minus 1. And z equal to z minus and z plus integer, and with 0 is called integers. Minus values and 0, 1, 2, 3, 4 plus values. These are called integers. Rational numbers, repeating or terminating at decimals, and a q is equal to x such that x equal to a by b, and a belongs to z and b belongs to z. B is not equal to 0. We can write these rational numbers in the form of p by q is called rational numbers. Irrational numbers, non-repeating and non-terminating decimals. We cannot write in the form of p by q, a by b. We cannot write in the form of a by b is called irrational numbers. Real numbers, union of rational and irrational numbers are called real numbers. In these real numbers, we have rational numbers and irrational numbers. Complex numbers are where x plus iy. I is the imaginary unit, and x belongs to r. X belongs to real number, and with imaginary numbers where y belongs to r. So these numbers are called complex numbers. Now look at here. What is the subset? N is subset of Z. Integers, natural numbers is subset of Z. And integers are subset of real numbers. Rational numbers. And rational numbers is subset of real numbers. Real numbers is subset of complex numbers. Now observe this. The natural numbers is here, and the whole numbers is added 0, and then integers means minus values and all these numbers, and the rational numbers is like 2 by 5, 17 by 35, 37 in the form of p by q, and irrational numbers are different from rational numbers, and real numbers have irrational and rational numbers. Pi, root 5, cubic root of 3, like these numbers are called irrational number, and pi is also irrational number, and all these rational, irrational and rational numbers are called real numbers. Now look at here, this outside 1 minus 4i, 2 plus 3i and 2i. These numbers are called complex numbers. In these complex numbers, we have all these numbers. Now the basic identities of the real numbers. ABC are the real numbers. Now additive identity a plus 0 equal to a. Additive inverse is a plus minus a equal to 0. And commutative of addition is a plus b equal to b plus a. Associative of addition is a plus b plus c is equal to a plus b plus c. Definition of subtraction: a minus b equal to a plus minus b. Multiplicative identity is a into 1 equal to a. Multiplicative of inverse is a into 1 by a is equal to 1, where a is not equal to 0. Multiplication of times 0 is 0, we know that a into 0 equal to 0. Commutative of multiplication is a into b equal to b into a. Associative of multiplication is a into b into c is equal to a into b into c. Distributive law: a into b plus c is equal to ab plus ac. Definition of division: a by b is equal to a into 1 by b. Some algebraic identities: a square minus b square is equal to a plus b into a minus b. A cube minus b cube is equal to a minus b into a square plus ab plus b square. A cube plus b cube is equal to a plus b into a square minus ab plus b square. A power 4 minus b power 4 is equal to a square minus b square into a square plus b square, that is a minus b into a plus b into a square plus b square. A power 5 minus b power 5 is equal to a minus b into a power 4 plus a cube b plus a square b square plus ab cube plus b power 4. And a power 5 plus b power 5 is equal to a plus b into a power 4 minus a cube b plus a square b square minus ab cube plus b power 4. If n is add, then a power n plus b power n is equal to a plus b into a power n minus 1 minus a power n minus 2 into b plus a power n minus 3 into b square minus and so ab whole power minus 2 plus b power n minus 1. And if n is even, then a power n minus b power n equal to a minus b into a power n minus 1 plus a power n minus 2 into b plus a power n minus 3 into b square plus so and so plus a power b power a into b power n minus 2 plus b power n minus 1. A minus b whole square is equal to a square minus 2ab plus b square. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. And a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A minus b whole power 4 is equal to a power 4 minus 4a cube b plus 6a square b square minus 4ab cube plus b power 4. A plus b whole power 4 equal to a power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b power 4. The binomial formula is a plus b whole power n equal to nc0 a power n plus nc1 a power n minus 1b plus nc2 a power n minus 2b square plus so and so nc n minus 1 a b power minus n minus 1 plus ncn b power n, where nck equal to, we know that formula, n factorial by k factorial into n minus k factorial. The binomial coefficients are there. Now 16th one, a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2ab plus 2bc plus 2ca. And a plus b plus c so and so plus u plus v whole square is equal to a square plus b square plus c square plus so and so u square plus v square plus 2 into 2a EAB plus AC plus so and so like that. You can write UB. A power m into a power n is equal to a power m plus n. A power m by a power n is equal to a power m minus n. AB whole power m equal to a power m into b power m. A by b whole power m equal to a power m by b power m. A power m whole power n is equal to a power m into n. A power 0 equal to 1 where a is not equal to 0. A power 1 equal to 1. A power minus m is equal to 1 by a power m. A power m by n is equal to nth root of a power m. Definition of logarithm. Y is equal to log x base a if and only if x is equal to a power y, where a greater than 0, a is not equal to 0. A power y is equal to x. If you apply log both sides, then log of a power y is equal to log x. So y log a is equal to log x base a. This is y equal to log x base a. Log 1 equal to 0. Log a base a equal to 1. Log 0 is greater than 1 and less than 1, it's infinity, not defined. Log xy base a equal to log x plus log y. Xy if two numbers are multiplied, we can write plus log x plus individually log y, and then log x by y is equal to log x by y is equal to log x minus log y. Here is into plus and divided by is minus. Log x power n base a equal to n log x base a. This power comes before n log x base a. Log nth root of x is equal to 1 by n log x base a. That root must be nth root must be 1 by n. We should write, because we know that log a nth root of x. Nth root of x means log base a x power 1 by n. This x power 1 by n should take before and 1 by n log x base a. Now log x base a equal to, we can write another base log x base c by log a base c. The bases are same, we can write this x and a. So this equal to log x base c into, also we can write the change into base into log function. So log x base c, here you should write into log c base a. Here is log a base c is there. If you denominator, uh, you should take into numerator, that changes base into logarithm. So log c base a. Now log c base a equal to, also we can write 1 by log a base c. X is equal to a power of log x base a. We can write this x log x here, and x equal to a log, here is base a and base, here is base a, base and base cancelled with log, and that means log a base a, and we should write that equal to x. Logarithm to base 10 is log x base 10 equal to log x. We can write this log x means the base always 10. The natural logarithm is log x base e, that is ln x log x. V value is, we know that 2.7182818288, so and so, that equal to limit k tends to infinity, where 1 plus 1 by k whole power k, that's value is this one. linear equation in one variable ax plus b equal to 0, where x value is the solution for x equal to minus b by a. And the quadratic equation ax square plus bx plus c equal to 0, and x1 value is x1 and x2 values are the solutions are here minus b plus or minus under root of b square minus 4ac by 2a. We have two values for the quadratic equation. Take x1 equal to plus and x2 is minus. And here is the b square minus 4ac is called discriminant. That is b square d, we can denote it as d equal to b square minus 4ac. Ax square plus bx plus c is greater than 0. That means a is greater than 0. When I is greater than 0, this value is greater than 0. It is a quadratic equation, and the discriminant is greater than 0. The curve should be like this. It's the x-axis. The curve should be like this, like u. X is less than x1, x is greater than x2. The values are always lies between, it is not lies between x1 and x2. So a greater than 0. If a greater than 0, if a less than 0, that means minus value. For example, 3x square plus 2x plus 3 or 4 something, it's a d is greater than 0. uh, b square 8x d, it's a equal to 0, where a is greater than 0 value. If it is minus 4 3x square means what? A is less than 0. The curve should be like this. uh, it is opposite to u. If discriminant is 0, a greater than 0, then the curve should be like here. It touches at a point x1 equal to x2, and it touches the x-axis, and it should be in the form of u, and a reverse of u, it touches at x1 equal to x2 value. The both solutions x1 and x2 are equal. Now d less than 0, it it should not touches the line x axis like this. And also if a less than 0, it should be inverse of u, and a greater than 0, it should be like this. The values are minus infinity to infinity lies between, and there is no x belongs to pi, there is no, it is not touches the line. There is no solution for this equation. In this triangle, the sides, it's opposite to a is called a, it is a, and opposite b is called b, opposite c is called c. The vertices are here, and alpha beta are the two angles. It is a right angle triangle because here is 90 degrees is there. So alpha plus beta, we know that angle A, alpha plus beta, and this 90, the sum of all the angles in a triangle up to 180 degrees. But also alpha plus beta equal to 90 degrees in right angle. So the alpha opposite side is A, and beta's opposite side is B, and C versus opposite side is C. It's called AB is called hypotenuse, because it's a biggest side in a right angle triangle. We know that ratio means two sides, comparison of two sides. Here is a sign alpha. Alpha opposite side is A, and the hypotenuse is C. A by C is called sine alpha. A by C is a ratio. Its name is sine. So alpha opposite side is A, and hypotenuse is C. A by C sine alpha equal to, and beta, a is adjacent side to a, beta, so adjacent side by hypotenuse is called cos theta. We can write cos beta. Sin alpha is equal to opposite side by hypotenuse, and cos beta is equal to beta's adjacent side by hypotenuse. And the alpha means adjacent side by hypotenuse is called cos alpha, and this b is opposite to beta, so beta opposite to beta, opposite side by hypotenuse is called sine. So cos alpha equal to b by c, that is sine beta, and tan alpha means opposite side by adjacent side, and it is opposite side, alpha opposite side is a, and beta's opposite side is b. So alpha opposite side is a and alpha adjacent side is b. Tan alpha equal to a by b, and that equal to cot beta. And cot alpha means adjacent side by opposite side. Adjacent side to alpha is b, and opposite side is a, b by a, that equal to tan beta. Beta's opposite side is beta, b by adjacent side is a, b by a, and sec alpha is equal to c by a, hypotenuse by adjacent side, c by b. This is called sec alpha. Sec alpha is hypotenuse by adjacent side, c by b. This is called opposite side to beta is b. So c by b is also known as cosec beta. Cosec alpha is equal to, alpha means hypotenuse by opposite side, that is c by a, also sec beta, adjacent side, hypotenuse by adjacent side is sec beta. Pythagoras theorem says that a square plus b square is equal to c square. The square of hypotenuse side is equal to the sum of squares of the remaining two sides. A square plus b square is equal to c square is called Pythagorean theorem.